Thank you for joining another math lesson hosted by Book&Table. I am your math tutor Maurice Wright, and this is practice set number 1 to our radical equations chapter. In this video, you will complete 20 questions that will help you practice removing one or several radical signs from an equation and solving for a variable x. Should you have any follow-up questions, feel free to leave them in our comment section. Or if you'd like to connect with a tutor in your neighborhood, visit bookandtable.com or download our app on the App Store. Okay, so we're going to kick things off with a radical equation that you'll wind up solving algebraically. Okay, questions 1 through 10 in this practice set you'll solve algebraically. Questions 11 through 15, you'll wind up solving using factoring. And questions 16 through 20, you'll wind up utilizing the quadratic formula. Let's begin. Question number 1. Solve for x and check the answers. The square root of x plus 3 minus 5 is equal to 0. Pause the video, answer this question, and then press play when you are ready to begin. Okay, so for a radical equation, you want to isolate the radical on one side of the equation. So step 1, add 5 to both sides. This eliminates our constant, negative 5, leaving us with just our radical on the left side, the square root of x plus 3. And on the right side, we have 0 plus 5, which gives us 5. Step 2, to eliminate this radical sign, we want to raise both sides of this equation to a power of 2. By doing so, we negate this index, which is 2, leaving us with just what is underneath the radical, which is x plus 3. Since we squared the left side to get rid of the radical, we must also square the right side. 5 squared gives us 25. So after step 2, we have x plus 3 is equal to 25. To solve for x now, we subtract 3 from both sides, leaving us with x is equal to 25 minus 3, which is x is equal to 22. We check this answer, step 4, by plugging it into the original equation. The square root of x plus 3 minus 5 is equal to 0. We plug in 22 for x, and that gives us the square root of 22 plus 3, which is the square root of 25, which is equal to 5. 5 minus 5 is 0. And here we see that the value on the left equals the value on the right side of the equation, proving that x does equal 22. Question number 2. Solve for x and check the answers. The square root of x minus 2 plus 1 is equal to 4. Pause the video, answer this question, and then press play when you are ready to begin. Step 1, subtract 1 from both sides. This removes the constant that's on the side of our radical, allowing us to isolate our radical, the square root of x minus 2. On the right side, we have 4 minus 1, which equals 3. Step 2, raise both sides to a power of 2. This eliminates the radical sign, leaving you with x minus 2 on the left side. And on the right side, 3 squared gives us 9. Step 3, since we have negative 2 on the left side, we want to remove it by adding 2 to both sides, giving us x is equal to 9 plus 2, which is 11. We check the answer by plugging it into the original equation. The square root of x minus 2 plus 1 is equal to 4. We plug in 11 for x, and that gives us the square root of 11 minus 2, which is the square root of 9, which is equal to 3. 3 plus 1 is equal to 4. So the left side equals the right side, proving that x does equal 11. Let's have a look at question number 3. Solve for x and check the answers. 2 times the square root of x minus 1 minus 3 is equal to 5. Pause the video, answer this question, and then press play when you are ready to begin. Step 1, add 3 to both sides. This gets rid of this constant, negative 3, isolating our radical term. On the right side, we have 5 plus 3, which gives us 8 on the right side. Step 2, raise both sides to a power of 2. Even though the coefficient is here, we can still raise both sides to a power of 2. So we square the coefficient as well. 2 squared gives you 4. Any radical squared gives you just the radicand, x minus 1. On the right side, we have 8 squared, which gives you 64. Now here we can solve algebraically, now that the radical is removed. And we can get rid of this term 4 by dividing both sides by 4, since this number, 64, is also divisible by 4. When you divide both sides by 4, you are left with x minus 1 on the left side. 64 divided by 4 is equal to 16. And now step 4, we can add 1 to both sides. That gives us x is equal to 17. Step 5, check the answer by plugging it into the original equation. 2 times the square root of x minus 1 minus 3 is equal to 5. Plug in 17 for x, and that gives you a term of the square root of 16. The square root of 16 is equal to 4. So that would give you 2 times 4, which is equal to 8. 8 minus 3 is equal to 5. Since the value on the left equals the value on the right, that confirms that x is equal to 17 is the correct answer for question number 3. Question number 4. Solve for x and check the answers. Negative 3 times the square root of x plus 5 plus 2 is equal to negative 1. Pause the video, answer this question, and then press play when you are ready to begin. Step 1, subtract 2 from both sides. That gets rid of the constant on the side of our radical, leaving us with negative 3 radical x plus 5 on the left side. On the right side, we have negative 1 minus 2, leaving us with negative 3 on the right side. Step 2, raise both sides to a power of 2. On the left side, negative 3 squared gives you 9. The square root of x plus 5 squared gives us x plus 5. On the right side, we have negative 3 squared, which is equal to 9. Step 3, we can divide both sides by 9 to get rid of this 9. That leaves us with x plus 5 on the left side. And on the right side, 9 divided by 9 is equal to 1. We can solve this equation algebraically by subtracting 5 from both sides, leaving us with x is equal to 1 minus 5, which is equal to negative 4. Step 5, check the answer by plugging it into the original equation, which was negative 3 times the square root of x plus 5 plus 2 is equal to negative 1. Plug in negative 4 for x, and that gives you a radical term of negative 4 plus 5, which is equal to positive 1. The square root of 1 is equal to 1. So negative 3 times 1 is equal to negative 3. Negative 3 plus 2 is equal to negative 1. Negative 1 is equal to negative 1 proves that x does in fact equal negative 4. Let's have a look at question number 5. Solve for x and check the answers. -2 times the square root of 3x plus 4 plus 5 is equal to 3. Pause the video, answer this question, and then press play when you are ready to begin. Step 1, subtract 5 from both sides, leaving you with -2 times the square root of 3x plus 4 on the left side. On the right side, we have 3 minus 5, which gives us -2. Step 2, raise both sides to a power of 2. -2 squared equals 4. The square root of 3x plus 4 squared is equal to 3x plus 4. And on the right side, we have -2 squared, which is equal to 4. You can now divide both sides by 4 for step 3, leaving you with 3x plus 4 on the left side. And on the right side, 4 divided by 4 is equal to 1. Step 4, now we can solve for x. So we can subtract both sides by 4 to get rid of this constant, +4, leaving us with 3x on the left side and 1 minus 4, which is equal to -3 on the right side. To get rid of this coefficient of +3, we'll divide both sides by 3, giving us an answer of x is equal to -1. Then the last step, check the answer by plugging it into the original equation. So we plug -1 in for x into our original equation. -2 times the square root of 3x plus 4 plus 5 is equal to 3. Plug in -1. 3 times -1 is -3. -3 plus 4 is equal to +1. The square root of +1 is +1. -2 times 1 is -2. -2 plus 5 is equal to +3, proving that x does in fact equal -1. Question number 6. Solve for x and check the answers. The square root of x plus 7 minus the square root of x is equal to 1. Pause the video, answer this question, and then press play when you are ready to begin. Okay, so for this question, this is the first question in this practice set that has 2 radicals in the original equation. For this, remember to isolate the first radical. So to do so, we want to move the second radical over to the right side of the equation. So step 1, add the second radical to both sides. This leaves you with the square root of x plus 7 on the left side and 1 plus the square root of x on the right side. Step 2, remove this radical sign by raising both sides to a power of 2, leaving you with x plus 7 on the left side. And now on the right side, you'll have 1 plus the square root of x squared. And we'll expand this expression by using the FOIL method. Remember, FOIL stands for first, outside, inside, last. So you'll multiply the first term inside the first binomial times each term in the second binomial. And then you'll take the second term in the first binomial and multiply it by each term in the second binomial. First terms, outside terms, inside terms, and then the last terms in each binomial. FOIL. So here we go. 1 times 1 equals 1. 1 times the square root of x is equal to the square root of x. The square root of x times 1 is equal to the square root of x. The square root of x plus the square root of x is equal to 2 square root of x. And lastly, the square root of x times the square root of x is equal to x. So with that, we have now removed our first radical. And now we want to isolate this second radical. So we want to subtract 1 from both sides and subtract x from both sides. So we're just left with this radical on the right side. So step 4, subtract x from both sides. And step 5, subtract 1 from both sides. X minus x gives you 0. 7 minus 1 gives you 6. So after that, we are left with 6 is equal to 2 times the square root of x. And now that we've isolated the second radical, we can raise both sides to a power of 2 to get rid of the radical. 6 squared is equal to 36. 2 squared is equal to 4. The square root of x times the square root of x is equal to x. Now we can solve for x by dividing both sides by 4. 36 divided by 4 gives us x is equal to 9. Lastly, check the answer by plugging it into the original equation. So we plug in 9 in both places where you see x, giving us the square root of 9 plus 7, which is equal to 16. The square root of 16 is equal to 4, minus the square root of 9, which is equal to 3. 4 minus 3 is equal to 1. The left side equaling the right side proves that x does equal 9. Question number 7. Solve for x and check the answers. The square root of x minus 3 plus the square root of x is equal to 3. Pause the video, answer this question, and then press play when you are ready to begin. Step 1. Subtract the second radical from both sides. This will help us isolate our first radical, the square root of x minus 3, on the left side of our equation. And now on the right side, we'll wind up with 3 minus the square root of x. To get rid of this first radical, we want to raise both sides to a power of 2. This eliminates the radical, leaving us with just x minus 3 on the left side. And on the right side, we have 3 minus the square root of x squared. And step 3, we'll use the FOIL method to expand this expression. 3 times 3 is equal to 9. 3 times negative the square root of x is equal to negative 3 radical x. Negative square root of x times 3 is equal to negative 3 square root of x. Negative 3 radical x and negative 3 radical x would combine to give us negative 6 radical x. And then negative square root of x times negative square root of x. Negative times negative is positive. Square root of x times square root of x is equal to x. So now that we've expanded the expression, we want to isolate the second radical now. So we'll want to move this term 9 to the left side. So we'll subtract 9 from both sides. And we'll move this positive x to the left side by subtracting x from both sides. So step 4, subtract x from both sides. X minus x is equal to 0. Step 5, subtract 9 from both sides. Negative 3 minus 9 is equal to negative 12. And now that we've isolated our second radical, we can raise both sides to a power of 2 to get rid of this radical. Negative 12 squared is equal to 144. Negative 6 squared is equal to 36. And the square root of x squared is equal to x. And now step 7, we can solve for x. Since the coefficient is 36, we'll divide both sides by 36, giving us x is equal to 144 divided by 36, which is equal to 4. And now step 8, We'll check the answer by plugging it into the original equation. The square root of x minus 3 plus the square root of x is equal to 3. Plug in 4 in both places where you see x. 4 minus 3 is equal to 1. The square root of 1 is equal to 1. 1 plus the square root of 4 is equal to 2. 1 plus 2 is equal to 3. And since the left equals the right, that proves that x does equal 4. Question number 8. Solve for x and check the answers. The square root of x plus 1 minus the square root of x minus 6 is equal to 1. Pause the video, answer this question, and then press play when you're ready to begin. Step 1. Add the second radical to both sides. This eliminates the second radical from the left side, isolating the first radical, the square root of x plus 1, on the left side of our equation. On the right side, we wind up with 1 plus the square root of x minus 6. We want to remove this radical sign. Since the index here is 2, we'll raise both sides to a power of 2, eliminating the radical, leaving us with just x plus 1 on the left side of our equation. On the right side, we have 1 plus the square root of x minus 6 squared. So we'll use the FOIL method to expand this expression in step 3. 1 times 1 is equal to 1. 1 times the square root of x minus 6 is equal to the square root of x minus 6. The square root of x minus 6 times 1 is equal to the square root of x minus 6. Since this coefficient is positive 1 and this coefficient is positive 1, and they are like terms, we can combine them to get 2 square root of x minus 6. And then the last terms, the square root of x minus 6 times the square root of x minus 6 is equal to x minus 6. So once we expand the expression, we wind up with x plus 1 is equal to 1 plus 2 radical x minus 6 plus x minus 6. You now want to isolate the second radical term, so you'll want to move everything else on this side to the left side of the equation. 1 minus 6 is equal to negative 5, so you'll add 5 to both sides to move those constants over to this side. And you'll subtract x from both sides to get rid of this variable here and move it to this side. So step 4, subtract x from both sides. X minus x is 0. And step 5, add 5 to both sides. I combine the 1 and negative 6 to get negative 5. Add 5 to cancel it here. 1 plus 5 is equal to 6. Now that you've isolated the second radical term, raise both sides to a power of 2. That eliminates this radical. 6 squared is equal to 36. 2 squared is equal to 4. The square root of x minus 6 squared is equal to x minus 6. You then want to distribute this 4 to each term. 4 times x is equal to 4x. 4 times negative 6 is equal to negative 24. And now that you've eliminated both radical signs from your equation, step 7, you can solve for x algebraically. Add 24 to both sides to get rid of this constant, leaving you with 4x is equal to 36 plus 24 is equal to 60. Then you can divide both sides by 4 to get rid of the coefficient of 4, leaving you with x is equal to 60 over 4, which is x is equal to 15. Step 8, check the answer by plugging it into the original equation. The square root of x plus 1 minus the square root of x minus 6 is equal to 1. plug 15 into both places where you see x. 15 plus 1 is 16. 15 minus 6 is 9. So that gives us the square root of 16 minus the square root of 9, which is equal to 4 minus 3, which is equal to 1. And since our left side equals the right side, that confirms that x does in fact equal 15. Question number 9. Solve for x and check the answers. The square root of x plus 12 plus the square root of x plus 23 is equal to 11. Pause the video, answer this question, and then press play when you are ready to begin. Step 1. Subtract the second radical from both sides. This isolates the first radical, the square root of x plus 12, on the left side of the equation. Now to get rid of the radical, you want to raise both sides to a power of 2, leaving you with x plus 12 on the left side. And on the right side, we wind up with 11 minus the square root of x plus 23 squared. And now step 3, we'll use the FOIL method to expand this expression here. 11 times 11 is equal to 121. 11 times negative square root of x plus 23 is equal to minus 11 radical x plus 23. Negative square root of x plus 23 times 11 is negative 11 square root of x plus 23. These are like terms, so we combine them by adding their coefficients. Negative 11 minus 11 is negative 22 radical x plus 23. And then you multiply the last terms in our binomials. Negative times a negative is a positive. A radical times itself gives you just the radicand, x plus 23. And now we want to isolate our second radical. So we want to move our variable to the left side. So we'll subtract x from both sides for step 4. And then for step 5, we'll subtract 144 from both sides. We'll combine 121 and 23 to give us 144. 144 in x. So we subtract both of those from both sides. X minus x is 0. 12 minus 144 is equal to negative 132. Now once we've isolated the second radical, we would normally raise both sides to a power of 2 here to eliminate this radical. But since 132 is divisible by 22, we can actually divide both sides by negative 22 here, just to help make the numbers a bit smaller. Negative 132 divided by negative 22 is equal to 6, and we get 6 is equal to the square root x plus 23. We still have our radical isolated, so we can raise both sides to a power of 2. 6 squared is equal to 36. The square root of x plus 23 squared is equal to x plus 23. Now you subtract 23 from both sides, giving you x is equal to 36 minus 23, which is 13. Step 9, check the answer by plugging it into the original equation. Plug 13 in both places where you see x, giving us the square root of 13 plus 12, which is 25. The square root of 13 plus 23, which is 36. The square root of 25 is 5, and the square root of 36 is 6. So 5 plus 6 is equal to 11, proving that x does in fact equal 13. Question number 10. Solve for x and check the answers. the square root of x plus 10 minus the square root of x minus 6 is equal to 2. Pause the video, answer this question, and then press play when you are ready to begin. Isolate the first radical by adding the second radical to both sides, eliminating it here, leaving you with just the square root of x plus 10 on the left side, and 2 plus the square root of x minus 6 on the right side. To eliminate this radical, raise both sides to a power of 2, leaving you with x plus 10 on the left side, 2 plus the square root of x minus 6 squared on the right side. For the third step, use the FOIL method to expand this expression on the right side. 2 times 2 is equal to 4. 2 times radical x minus 6 is equal to 2 radical x minus 6. Radical x minus 6 times 2 is plus 2 radical x minus 6. Since these are like terms, we combine them by adding their coefficients. 2 plus 2 is equal to 4. Then lastly, the square root of x minus 6 times the square root of x minus 6 is equal to x minus 6. Now that we've eliminated the first radical, we want to isolate the second radical. 4 minus 6 is equal to negative 2. So step 4, subtract x from both sides to move the x over. And step 5, add 2 to both sides to move the 2 over. That leaves just our radical term on the right side. And on the left side, x minus x is 0. And 10 plus 2 is equal to 12. Here, we can raise both sides to a power of 2. Or, since this coefficient is 4, and we can divide this number by 4, we can eliminate the coefficient here, just to try and make the numbers a bit smaller. So divide both sides by 4, giving you 3 is equal to radical x minus 6. Now we can raise both sides to a power of 2. 3 squared is equal to 9. Any radicals squared is just the number or expression underneath, which in this case is x minus 6. And now we can solve for x by adding 6 to both sides, giving us x is equal to 15. Then the last step, step 9, check the answer by plugging it into the original equation. Plug 15 into both places where you see x, giving you the square root of 25, which is equal to 5. And the square root of 15 minus 6 is 9, and the square root of 9 is 3. 5 minus 3 is equal to 2. 2 equals 2 proves that x does equal 15. Question number 11. Remember, for questions 11 through 16, you will now utilize factoring to help you find the value or values of x. Solve for x and check the answers. The square root of 2x plus 3 minus x is equal to 0. Pause the video, answer this question, and then press play when you are ready to begin. Step 1, add x to both sides. This helps you isolate the first radical on the left side of the equation. And now to eliminate this radical sign, step 2, raise both sides to a power of 2. This leaves you with 2x plus 3 on the left side and x squared on the right side. The variable now appears twice and in different degrees. So this is to a degree of 2, this is to a degree of 1, so we won't be able to combine them. So instead we want to move these two terms to this side to create a polynomial. So step 3, subtract 2x from both sides. In step 4, subtract 3 from both sides. 2x minus 2x is equal to 0. 3 minus 3 is equal to 0, which is what we want. We want 0 on one side of our equation and the remaining terms on the other side. X squared minus 2x minus 3. So once we have a quadratic and we confirm that the coefficient of x squared is equal to 1, we want to examine b, our coefficient of x, which is -2, and c, our constant, -3. Specifically, we want to ask ourselves, are there factors of c that have a sum of b? And the answer is yes. -3 times +1 is equal to -3. And their sum is -3 plus 1, which is equal to -2. So we factor the polynomial by taking those values, -3 and +1, and adding them to x inside a pair of parentheses. So once we complete step 5, factor the polynomial, we have 0 is equal to x minus 3 times x plus 1. And now we set each of these factors equal to 0. And now we solve for x. X minus 3 is equal to 0. So we add 3 to both sides, giving us one potential value of x, which is x is equal to 3. And now the second potential value for x, we have x plus 1 is equal to 0. So we subtract 1 from both sides, giving us x is equal to -1. And now that we have these two potential values, check the answers by plugging each number into the original equation. The square root of 2x plus 3 minus x is equal to 0. So we'll first test -1 by plugging it into both places where we see x. 2 times -1 is -2. -2 plus 3 is equal to +1. Minus -1 is equal to +1. The square root of 1 is equal to 1. So we wind up with 1 plus 1, which is equal to 2. And that does not equal 0. So that shows that x does not equal -1. That number does not work. Let's try our second number, 3. 2 times 3 is 6. 6 plus 3 is 9. The square root of 9 is 3. And 3 minus 3 is equal to 0. Now this shows that x does equal 3. Question number 12. Solve for x and check the answers. The square root of 4x plus 1 minus x is equal to -1. Pause the video, answer this question, and then press play when you are ready to begin. Step 1, add x to both sides. This isolates the radical, the square root of 4x plus 1 on the left side of the equation. And now on the right side, we have positive x minus 1. So now step 2, raise both sides to a power of 2, leaving you with 4x plus 1 on the left side. And on the right side, we have x minus 1 squared. We'll use the FOIL method in step 3 to expand this expression. X times x is equal to x squared. X times -1 is equal to -x. -1 times x is equal to -x. We combine these two terms to give us -2x. And -1 times -1 is +1. So we see here, our variable appears twice. These two have the same degree, so we'll be able to combine these two, but we won't be able to combine them with this one. So once we see that, we want to move all of our terms to one side of our equation. So we subtract 4x from both sides, and we subtract 1 from both sides, giving us 0 is equal to x squared. Negative 2x minus 4x is negative 6x. 1 minus 1 is 0. We wind up with 0 is equal to x squared minus 6x. And we can factor this by removing an x from each of these two terms. Take one of the two x's out. We take the x away from negative 6. If you're unsure if you reverse distributed the variable correctly, just ask yourself, if you were to expand this, what would you get? X times x is x squared. X times negative 6 is negative 6x. So we have factored the polynomial correctly. So step 7, set each of these factors equal to 0. So x is equal to 0 winds up being one of our potential values. And we set this factor, x minus 6, equal to 0, and we solve for x. Add 6 to both sides, giving you x is equal to 6 as our second possible value. And now step 9, check the answers by plugging each number into the original equation. So we'll first test 0. 4 times 0 is equal to 0. 0 plus 1 is equal to 1. The square root of 1 is equal to 1. 1 minus 0 is equal to 1. And 1 does not equal negative 1. So that means x does not equal 0. For 6, 4 times 6 is 24. 24 plus 1 is equal to 25. The square root of 25 is equal to 5. And 5 minus 6 is equal to negative 1. And since the left side equals the right side here, that shows that x does in fact equal positive 6. Question number 13. Solve for x and check the answers. The square root of x squared minus 2 minus the square root of x plus 4 is equal to 0. Pause the video, answer this question, and then press play when you are ready to begin. Isolate the first radical. You do so by moving the second radical over to the right side. So step 1, add the second radical to both sides, giving you the square root of x squared minus 2 is equal to the square root of x plus 4. Eliminate this radical by raising both sides to a power of 2. This winds up eliminating both radicals, since this radical was isolated on this side as well. That leaves us with x squared minus 2 on the left side and x plus 4 on the right side. We'll now move these terms to one side of our equation. So step 3, subtract x from both sides. And step 4, subtract 4 from both sides. So we wind up with x squared minus x, and negative 2 minus 4 is equal to negative 6. So 0 is equal to x squared minus x minus 6. And now we want to factor this polynomial. So what are the factors of negative 6 that have a sum of negative 1? That would be negative 3 and positive 2. So step 5, we factor the polynomial. And when we do so, we wind up with x minus 3 times x plus 2. Remember, we're looking for the factors of negative 6 that have a product of negative 6. Negative 3 times positive 2 is negative 6. And a sum of b, negative 1. Negative 3 plus 2 is negative 1. So this is the polynomial factored. And now step 6, set each factor equal to 0. X minus 3 is equal to 0. So we'll solve this for x. And x plus 2 is equal to 0. So we'll solve this for x. X minus 3 is equal to 0. We add 3 to both sides, giving us x is equal to 3. And the second factor, x plus 2, we set that equal to 0 and subtract 2 from both sides, giving us x is equal to negative 2. And now we check the answers by plugging each number into the original equation. The square root of x squared minus 2 minus the square root of x plus 4 is equal to 0. So we'll first plug in negative 2 in for x. Negative 2 squared is 4. 4 minus 2 is 2. Negative 2 plus 4 is 2. The square root of 2 minus the square root of 2 is 0. So since this shows that the left side equals the right side, x did in fact equal negative 2. The second value, 3. 3 squared is 9. 9 minus 2 is 7. 3 plus 4 is 7. So we wind up with radical 7 minus radical 7, which is 0. So since the left side equals the right side, that proves that x also equals positive 3. Let's now take a look at question number 14. Solve for x and check the answers. The square root of 2x plus 3 minus the square root of x plus 1 is equal to 1. Pause the video, answer this question, and then press play when you are ready to begin. Step 1, add the second radical to both sides, leaving you with the square root of 2x plus 3 on the left side is equal to 1 plus the square root of x plus 1 on the right side. To remove this radical, we want to raise both sides to a power of 2, leaving you with 2x plus 3 on the left side. And on the right side, we have 1 plus radical x plus 1 squared. And we'll use the FOIL method to expand this expression on the right side. 1 times 1 is equal to 1. 1 times the square root of x plus 1 is equal to the square root of x plus 1. The square root of x plus 1 times 1 is still the square root of x plus 1. And since these are like terms, we combine them by adding their coefficients, 1 and 1, which gives us 2. And then we have the square root of x plus 1 times itself, which leaves us with just the value underneath, x plus 1. Now we want to isolate this second radical, so we move our constants, 1 and 1, which are 2. Move 2 over, and we move x over, our variable. So 2x minus x is x. 3 minus 2 is 1. So we wind up with x plus 1 is equal to 2 radical x plus 1. So now we can raise both sides to a power of 2 to get rid of this second radical, giving us x plus 1 squared on the left side. And we'll use the FOIL method to expand this expression. And on the right side, we have 2 squared, which is 4. Radical x plus 1 squared is equal to x plus 1. Distribute this 4, and you get 4x plus 4. And now step 7, again, we'll use the FOIL method to expand this expression over here. I turn the expression around, so we have 4x plus 4 on the left side, and x plus 1 squared on the right side. X times x is equal to x squared. X times 1 is equal to x. 1 times x is equal to x. X plus x is 2x. And then lastly, 1 times 1 is equal to 1. We now want to move these terms from the left side to the right side. So step 8, subtract 4x from both sides. And step 9, subtract 4 from both sides, giving us 0 on the left side of our equation. And on the right side, you have x squared 2x minus 4x, which is negative 2x, and 1 minus 4, which is negative 3. Step 10, you are now going to factor the polynomial. So what are the factors of negative 3 that have a sum of negative 2? Negative 3 and positive 1. Negative 3 times 1 is negative 3. Negative 3 plus 1 is equal to negative 2. So after we factor the polynomial, we have 0 is equal to x minus 3 times x plus 1. Now step 11, you set each factor equal to 0. So x minus 3 is equal to 0, and x plus 1 is equal to 0. And then step 12, you solve each one of those for x. So for the first one, we add 3 to both sides, giving us x is equal to 3. And for our second factor, x plus 1, we subtract 1 from both sides to give us x is equal to negative 1. Step 13, check the answers by plugging each number into the original equation. Plug negative 1 into both places where you see x. 2 times negative 1 is negative 2. Negative 2 plus 3 is equal to positive 1. The square root of positive 1 is 1. For our second radical term, we have negative 1 plus 1, which is 0. The square root of 0 is 0. 1 minus 0 is equal to 1. So since our left side equals the right side, that confirms that x does equal negative 1. And then when we test 3, 2 times 3 is equal to 6. 6 plus 3 is equal to 9. The square root of 9 is equal to 3. For our second term, we have 3 plus 1, which is equal to 4. The square root of 4 is equal to 2. So 3 minus 2 is equal to 1. And again, since the left side equals the right side here, that confirms that x also equals positive 3. Let's now have a look at question number 15. Solve for x and check the answers. The square root of 3x plus 4 minus the square root of 2x minus 4 is equal to 2. Pause the video, answer this question, and then press play when you are ready to begin. Step 1. Add the second radical to both sides, isolating the first radical. So you have the square root of 3x plus 4 is equal to 2 plus the square root of 2x minus 4. Now that you've isolated this radical, you want to eliminate the radical sign by raising both sides to a power of 2, leaving you with 3x plus 4 on the left side. And on the right side, we have 2 plus the square root of 2x minus 4 squared on the right side. For step 3, we'll use the FOIL method to expand this expression. 2 times 2 is equal to 4. 2 times the square root of 2x minus 4 is equal to 2 times the square root of 2x minus 4. The square root of 2x minus 4 times 2 again gives us 2 radical 2x minus 4. We combine these like terms by adding their coefficients. 2 plus 2 gives you 4. Then lastly, radical 2x minus 4 times itself gives you 2x minus 4. 4 minus 4 gives you 0, so those eliminate each other. So we'll subtract 2x from both sides to get rid of the 2x. 3x minus 2x is x, plus 4 is equal to 4 radical 2x minus 4. Now that the second radical is isolated, you can raise both sides to a power of 2 to eliminate it. So you wind up with x plus 4 squared on the left side. We'll use the FOIL method again to expand this expression. And on the right side, we have 4 squared, which is equal to 16. And radical 2x minus 4 times itself is 2x minus 4. We can expand this by distributing the 16 to each term. 16 times 2x is 32x, and 16 times negative 4 is negative 64. And now we can expand this expression with the FOIL method. So we have 32x minus 64 is equal to x times x, which is x squared, x times 4, which is 4x, 4 times x, which is 4x, 4x plus 4x equals 8x, and 4 times 4 equals 16. So now that our radicals are removed, we want to move these two terms to this side, so we get 0 on one side of our equation. So step 7, subtract 32x from both sides. And step 8, add 64 to both sides, giving us 0 is equal to x squared. 8x minus 32x is negative 24x. And 16 plus 64 is 80. Now, what factors of 80 have a sum of negative 24? That would be negative 20 and negative 4. So step 9, factor the polynomial. That would be x minus 20 times x minus 4. And then step 10, we set each of these equal to 0. And then step 11, we'll solve each of these for x. So x minus 20 is equal to 0. You add 20 to both sides, giving you x is equal to 20. For this factor, x minus 4 is equal to 0. You add 4 to both sides, leaving you with x is equal to positive 4. Step 12, check the answers by plugging each number into the original equation. So we'll plug in 4 into each place where we see x. 3 times 4 is 12. 12 plus 4 is 16. 2 times 4 is 8. 8 minus 4 is 4. So that gives us the square root of 16, which is 4, minus the square root of 4, which is 2. 4 minus 2 is equal to 2. And since we have 2 is equal to 2 at the end, that confirms that x does equal positive 4. Let's now check 20. Plug 20 into both places for x, and that'll give you 3 times 20, which is 60. 60 plus 4 is 64. The square root of 64 is equal to 8. Minus the square root of 2 times 20, which is 40. 40 minus 4 is 36. And the square root of 36 is equal to 6, leaving us with 8 minus 6, which is equal to 2. 2 equals 2 confirms that x is also equal to 20. So x is equal to both 4 and 20. Let's now move on to question number 16. For the remaining questions, 16 through 20, you will now utilize the quadratic formula to help you solve for x. Solve for x and check the answers. The square root of 4x plus 8 minus 3x is equal to negative 2. Pause the video, answer this question, and then press play when you are ready to begin. Step 1, add 3x to both sides, isolating the first radical on the left side, and leaving you with 3x minus 2 on the right side. Step 2, raise both sides to a power of 2 to get rid of this first radical, leaving you with 4x plus 8 on the left side, and 3x minus 2 squared on the right side. And now step 3, use the FOIL method to expand this expression on the right. 3x times 3x is 9x squared. 3x times negative 2 is negative 6x. Negative 2 times 3x is negative 6x. Negative 6x minus 6x is negative 12x. and negative 2 times negative 2 is positive 4. Step 4, we now want to subtract 4x from both sides to move this over. And step 5, we want to subtract 8 from both sides to move that over, giving us our desired 0 on the left side. And on the right side, we have 9x squared. Negative 12x minus 4x is negative 16x. And 4 minus 8 is negative 4. So now we have this quadratic, 9x squared minus 16x minus 4. So our a term is the coefficient of x squared, which is 9. Our b term is the coefficient of x, which is negative 16. And our c term is the constant negative 4. So step 6, plug a, b, and c into the quadratic formula. And then step 7, solve for x. So we'll plug in negative 16 here and here. We'll plug in 9 here and here. And we'll plug in negative 4 here, giving us negative 1 times negative 16 plus or minus the square root of negative 16 squared minus 4 times 9 times negative 4 over 2 times 9. So this is what we want to evaluate to solve for x. So we'll start with negative 1 times negative 16 is 16 over 2 times 9, which is 18, plus or minus negative 16 squared is 256. Negative 4 times 9 is negative 36. Negative 36 times negative 4 is positive 144. 256 plus 144 is equal to 400. And the square root of 400 is equal to 20. So x has two potential values, 16 over 18 minus 20 over 18, which is negative 4 over 18. And 16 over 18 plus 20 over 16 would give you 36 over 18. This first value becomes negative 2 over 9, which is negative 0.22. And 36 divided by 18 is equal to 2. So x is equal to negative 0.22 and positive 2. Now step 8. Check the answers by plugging each number into the original equation. The square root of 4x plus 8 minus 3x is equal to negative 2. So we'll plug in negative 0.22 in both places where we see x. 4 times negative 0.22 is equal to negative 0.88. Negative 0.88 plus 8 is equal to positive 7.12. And the square root of 7.12 is equal to 2.66. Negative 3 times negative 0.22 is equal to positive 0.66. 2.66 plus 0.66 is equal to positive 3.32, which does not equal negative 2. So x does not equal negative 0.22. Check the second answer, positive 2. 4 times 2 is equal to 8. 8 plus 8 is equal to 16. The square root of 16 is equal to 4. 4 minus 6 would give you negative 2. The left equals the right here, confirming that x does equal positive 2. Question number 17. Solve for x and check the answers. The square root of 3x squared minus 4x minus 2 is equal to 0. Pause the video, answer this question, and then press play when you're ready to begin. Step 1, add 2 to both sides, giving you the square root of 3x squared minus 4x is equal to 2. So we have successfully isolated our radical on the left side. And now we can eliminate the radical by step 2, raising both sides to a power of 2, leaving you with 3x squared minus 4x on the left side, and 2 squared, which is equal to 4 on the right side. We now want to subtract 4 from both sides to move this to this side, giving us 0 is equal to 3x squared minus 4x minus 4. And now we have our polynomial or quadratic term that we can use to get values a, b, and c. So a is equal to 3, b is equal to negative 4, and c is equal to negative 4. So we'll plug these values into the quadratic formula and then solve for x. So negative 4 gets plugged in for b here and here. 3 gets plugged in for a here and here. And negative 4 gets plugged in for c here, giving us this. And now we'll evaluate this expression. Negative 1 times negative 4 is positive 4. 2 times 3 is 6. Plus or minus. Negative 4 squared is 16. Minus 4 times 3, which is negative 12. Negative 12 times negative 4 is positive 48. 48 plus 16 is 64. And the square root of 64 is equal to 8. So x has two potential values, 4 over 6 minus 8 over 6, which is equal to negative 4 over 6. And 4 over 6 plus 8 over 6 is equal to 12 over 6. So we see that x is equal to negative 2/3 and 2. And then the last step, check the answers by plugging each number into the original equation. So we'll first test negative 0.66. We plug in negative 0.66 in both places where we see x. We wind up getting 4 as our radicand here. And the square root of 4 is equal to 2. 2 minus 2 gives us 0. And 0 equaling 0 confirms that x does equal negative 2/3. And then we'll test the second value, positive 2. We plug it in both places where we see x. 2 squared is 4, times 3 is 12. 12 minus 8 is 4. The square root of 4 is 2, leaving you with 2 minus 2, which gives you 0, confirming that x also equals positive 2. Question number 18. Solve for x and check the answers. The square root of x squared plus 3x minus 4 minus 2x is equal to negative 4. Pause the video, answer this question, and then press play when you are ready to begin. Step 1, add 2x to both sides. That gives us the square root of x squared plus 3x minus 4 on the left side, and 2x minus 4 on the right side. Step 2, eliminate this radical by raising both sides to a power of 2, leaving you with x squared plus 3x minus 4 on the left side, and 2x minus 4 squared on the right side. And now use the FOIL method to expand this expression on the right side. 2x times 2x is equal to 4x squared. 2x times negative 4 is equal to negative 8x. Negative 4 times 2x is equal to negative 8x. Negative 8x minus 8x is equal to negative 16x. And negative 4 times negative 4 is equal to positive 16. We now want to move these three terms over to the right side. Step 4, subtract x squared from both sides. Step 5, subtract 3x from both sides. And then step 6, add 4 to both sides. So that gives us 0 on the left side and our quadratic on the right side. And now we can plug a, b, and c into the quadratic formula for step 7. A is the coefficient of x squared, so a is equal to 3. B is the coefficient of x, so b is equal to negative 19. And c is equal to 20. We plug those values into their respective positions in the quadratic formula, and we get negative 1 times negative 19 plus or minus the square root of negative 19 squared minus 4 times 3 times 20 over 2 times 3. That gives us 19 over 6 plus or minus negative 19 squared, which is 361, minus 4 times 3 times 20, which is negative 240. 361 minus 240 is equal to 121. And the square root of 121 is equal to 11, showing us that x has two potential values, 19 over 6 minus 11 over 6, which would be 8 over 6, and 19 over 6 plus 11 over 6, which is 30 over 6. So we see x is equal to 1 1/3 and 5. And now we check the answer by plugging each number into the original equation. So we plug in 1.33 into all three places where we see x. When we do so, underneath our radical, 3 times 1 1/3 is equal to 4. 4 minus 4 leaves us with 1.33 squared. The square root of a value squared is equal to just that number, 1.33. Negative 2 times 1.33 is negative 2.66. 1.33 minus 2.66 is negative 1.33, which is not equal to negative 4. So we see x does not equal 1 1/3. We test the second potential value, 5. 5 squared is 25. Plus 15 would be equal to 40. 40 minus 4 is equal to 36. The square root of 36 is 6. Minus 2 times 5, which is 10. 6 minus 10 is equal to negative 4. Since negative 4 is equal to negative 4, that confirms that x does equal positive 5. Question number 19. Solve for x and check the answers. The square root of 2x plus 4 minus 2 times the square root of x plus 3 is equal to negative 2. Pause the video, answer this question, and then press play when you are ready to begin. Step 1, add the second radical to both sides to isolate the first radical, the square root of 2x plus 4 on the left side. And now on the right side, we have 2 radical x plus 3 minus 2. Now to eliminate this radical, raise both sides to a power of 2, leaving you with 2x plus 4 on the left side and 2 radical x plus 3 minus 2 squared on the right side. So we'll use the FOIL method to expand this expression on the right. 2 times 2 is 4. The radical times itself gives us x plus 3. 4 times x is 4x, and 4 times 3 is 12. Next, we have 2 radical x plus 3 times negative 2. Negative 2 times positive 2 is negative 4. Radical x plus 3. Negative 2 times positive 2 is negative 4 times radical x plus 3. These are like terms, so we combine them by adding their coefficients. Negative 4 minus 4 is negative 8. Radical x plus 3. Then lastly, negative 2 times negative 2 is positive 4. So now we want to isolate our second radical. So we'll move all the other terms over to the left side. We'll combine the 12 and the 4 to give us 16. And now step 4, subtract 4x from both sides. In step 5, subtract 16 from both sides, giving you 2x minus 4x, which is negative 2x. 4 minus 16 is negative 12, is equal to negative 8 radical x plus 3. And now we can eliminate this radical by raising both sides to a power of 2, giving us negative 2x minus 12 squared on one side, and negative 8 squared, which is 64, times radical x plus 3 squared, which is x plus 3. Distribute the 64 to the x and to the 3, giving us 64x plus 192. Now for step 7, use the FOIL method to expand the expression, this one. So we get 64x plus 192 is equal to negative 2x times negative 2x is 4x squared. Negative 2x times negative 12 is positive 24x. Negative 12 times negative 2x is positive 24x. Combine these two terms to give us positive 48x. And negative 12 times negative 12 is positive 144. So we want to move 64x and 192 to this side. So step 8, subtract 64x from both sides. And step 9, subtract 192 from both sides, giving us our desired 0 on one side. And that's equal to 4x squared minus 16x. 48 minus 64 is negative 16. And 144 minus 192 is negative 48. Now here, you can extract the 4 from each term. But let's say you don't notice that. You can still utilize the quadratic formula at this step to solve for x. So step 10, plug a, which is 4, b, which is negative 16, and c, which is negative 48, into the quadratic formula. And when you do, you get this, negative 16 in for b, 4 in for a, and negative 48 for c. So that's the expression that we want to evaluate. Negative 1 times negative 16 is positive 16. 2 times 4 is 8. Plus or minus. Negative 16 squared is 256. Negative 4 times positive 4 is negative 16. Times negative 48 is positive 768. 256 plus 768 is 1024. And the square root of 1024 is equal to 32. So x has two potential values. 16 over 8 minus 32 over 8 is negative 16 over 8, which is negative 2. And 16 over 8 plus 32 over 8 would give you 48 over 8, which is equal to 6. So we get x is equal to negative 2 and positive 6. And that leads us to step 12. Check the answers by plugging each number into the original equation. So plug in negative 2 in both places where you see x, and that'll give you 2 times negative 2, which is negative 4. Negative 4 plus 4 is 0. Square root of 0 is 0. Negative 2 plus 3 is positive 1. The square root of 1 is 1. And 2 times 1 is equal to 2. So we get 0 minus 2, which is negative 2. And negative 2 equals negative 2 confirms that x does equal negative 2. And now we test the second value, 6. 2 times 6 is 12. 12 plus 4 is 16. The square root of 16 is equal to 4. The second radical, 6 plus 3 is 9. The square root of 9 is 3. And 3 times 2 is 6. So we wind up with 4 minus 6, which is equal to negative 2 as well, showing that x also equals positive 6. And now let's take a look at the last question of this practice set, question number 20. Solve for x and check the answers. The square root of 3x plus 7 minus the square root of x plus 1 is equal to 2. Pause the video, answer this question, and then press play when you are ready to begin. Step 1, add the second radical to both sides, giving you the square root of 3x plus 7 is equal to 2 plus the square root of x plus 1. Step 2, raise both sides to a power of 2, giving you 3x plus 7 on the left side is equal to 2 plus the square root of x plus 1 squared on the right side. And now step 3, use the FOIL method to expand this expression on the right. 2 times 2 is equal to 4. 2 times the square root of x plus 1 is 2 radical x plus 1. Radical x plus 1 times 2 is 2 radical x plus 1. These are like terms, so you combine them by adding the coefficients 2 and 2 to get 4 radical x plus 1. And radical x plus 1 times itself gives us x plus 1. We want to isolate our second radical. So 4 plus 1 is 5. So we want to move 5 over to this side. And we want to move x over to this side. So step 4, subtract x from both sides. And step 5, subtract 5 from both sides. 3x minus x is 2x. And 7 minus 5 is 2. And that's equal to 4 radical x plus 1. Square both sides now to eliminate this radical, giving you 2x plus 2 squared on the left side. 4 squared is 16 times x plus 1 on the right side. The radical times itself gives you x plus 1. 16 times x is 16x. 16 times 1 is 16. And now we'll use the FOIL method to expand the expression here. 2x plus 2 squared. So we get 2x times 2x, which is 4x squared. 2x times 2, which is equal to 4x. 2 times 2x, which is equal to 4x. Combine 4x and 4x to give you 8x. And 2 times 2 is equal to 4. Move these terms over to this side, so we get 0 on one side. So step 8, subtract 16x from both sides. In step 9, subtract 16 from both sides, giving you 0 on the left side. And on the right side, we have 4x squared. 8x minus 16x is negative 8x. And 4 minus 16 is negative 12. So you can extract 4 from each term here, but let's say that you didn't catch that. You can still use the quadratic formula with these values to solve for x. So a is equal to 4, b is equal to negative 8, and c is equal to negative 12. If you took 4 out of each term and you had different values for a, b, and c, the final value should still be the same. All right, so that shouldn't mess up the final answers. But we're going to use these numbers and plug them into the quadratic formula. And then we'll evaluate that expression. -1 times -8 is +8, divided by 2 times 4, which is 8, plus or minus. -8 squared is 64, minus 4 times 4 times -12, which is +192. 192 plus 64 is equal to 256, and the square root of 256 is 16. So x has two potential values. 8 over 8 minus 16 over 8 is -8 over 8, which is -1. And 8 over 8 plus 16 over 8 is 24 over 8, which is 3. So x is equal to -1 and +3. Then the last step, step number 12, check the answers by plugging each number into the original equation. So we'll test -1 first. 3 times -1 is -3, plus 7 is +4. The square root of 4 is 2. -1 plus 1 is 0. The square root of 0 is 0. So we wind up with 2 minus 0, which is 2. And since 2 is equal to 2, that confirms that x does equal -1. Then the second value, +3. 3 times 3 is 9. 9 plus 7 is 16. The square root of 16 is 4. Minus the square root of 3 plus 1, which is 4. The square root of 4 is 2. 4 minus 2 is equal to 2, confirming that x is also equal to +3.
And that wraps up practice set number 1 to our Solving Radicals chapter. Should you have any follow-up questions, feel free to leave them in the comment section, or you can contact a tutor in your neighborhood by visiting bookandtable.com or by downloading our app on the App Store. Peace.